In this lesson, we are going to discuss about potential energy and kinetic energy in SHM. Potential energy at the mean position is minimum. Potential energy at the mean position, we can take it to be 0. So potential energy at any position is the work done against the restoring force to take the particle from the mean position to the current position. Restoring force is minus kx. So against the restoring force, you apply a force equal to kx. So potential energy is the work done against the restoring force to take the particle from 0 to x dx. We are assuming that the potential energy at mean position is 0. And if we do this integration, which is very easy, we get half kx square. So this is the formula for potential energy. At the mean position, potential energy is minimum and we are taking it to be 0. Now, we know that omega is root over k by m. So therefore, k is m omega square. So this equation for potential energy becomes half m omega square x square. Now x we know is a cos omega t plus phi naught, that's what we have taken. So therefore this equation becomes half m omega square a square cos square omega t plus phi naught. At the mean position, potential energy is minimum, we are taking it to be equal to 0. At the extreme position, potential energy is maximum. So U is maximum at x equal to a, and that maximum value is half k square or half m omega square a square. This is the maximum value of potential energy. This is the value at extreme position. If we look at kinetic energy will simply be given by half mv square. So kinetic energy is half mv square. Velocity equation already we know. So we can write the equation of kinetic energy also very easily. Kinetic energy is half mv square. V is minus omega a sine omega t plus phi naught this is squared here, so we get kinetic energy is half m omega square a square sine square omega t plus phi naught. And this we can also write as half k square, because m omega square is k, half k square sine square omega t plus phi naught. This is the equation for kinetic energy in SHM. V is also equal to minus omega root over a square minus a square. Therefore, this can also be written as half m minus omega root over a square minus x square whole square, that is half m omega square a square minus x square. Kinetic energy is minimum at the extreme position. The kinetic energy at x equal to a is 0, it has to come to rest there. And kinetic energy is maximum at the mean position, and that is equal to half m omega square a square, and that is half k a square.